Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. An administrator deploys a brand new Azure virtual machine for testing. Everything works perfectly. To make remote access easier, they assign a public IP address and leave remote desktop open to the internet just for today. Weeks later, the server is still exposed. No one remembers it exists. Automated scanners eventually discover the open port and begin trying thousands of passwords every hour. Nothing is wrong with Azure. Nothing is wrong with Windows. The problem is a network that trusted everyone. Today, you'll learn how Azure networking prevents exactly this situation by combining virtual networks, subnets, network security groups, and application security groups into a secure, layered design. By the end of this lesson, you'll know how to build networks that allow only the traffic you intend and deny everything else. Let's quickly recap what you've already conquered. In Part 1, you decoded VM names and the B-Series burst credit system. In Part 2, you saw why a VM's throughput cap matters, even with ultra-disk IOPS. Today, we move to the network layer that either keeps your VMs safe or leaves them wide open. Attackers constantly scan for open management ports like RDP, and a missing NSG rule is a common entry point. By the end of this video, you'll know how to make sure you're never that target. By the end of this video, you'll be able to do 3 things that will keep your Azure VMs secure. First, you'll configure a network security group rule that allows RDP only from your specific IP address, closing the door that attackers use. Second, you'll use application security groups to collapse dozens of rules into a single one, eliminating rule explosion. Third, you'll design a full 3-tier architecture with web, business, and data layers, each locked down with least privilege NSG and ASG rules. These are the skills that turn a misconfigured VM into a hardened system. One VNet is not a flat network. You carve it into subnets, smaller IP blocks that let you group resources by function. Here we have a web subnet, an app subnet, and a database subnet. But here's a hidden gotcha. Azure silently reserves a handful of IP addresses per subnet: the network ID, the gateway, a couple for DNS services, and the broadcast address. So a /24 with 256 total addresses gives you fewer usable than you might expect. Always check the current documentation for the exact count, but the key takeaway is plan for that overhead. Internal traffic crosses subnets instantly, and each can carry its own firewall rules. That segmentation makes a multi-tier design possible. Time to lock it in. We just discussed that Azure silently reserves a few addresses: the network ID, gateway, DNS services, and broadcast. Which IPs get sacrificed? Answer: those 4 or more are taken, so the usable count drops. In a 28 subnet, for example, that leaves only a handful of addresses actually available for your VMs. Always verify the exact reserved count in the current Azure docs, but the concept is what matters. A /24 subnet has 256 addresses. How many can you assign to VMs? Not all of them. Azure sets aside a few IPs: network ID, gateway, DNS, and broadcast. That's the number you'll budget for in every design, even if you don't need to recite the exact count on an exam. A VM isn't wired directly to a subnet. It connects through one or more network interface cards. A NIC holds the IP, MAC, and security settings. You can attach multiple NICs to isolate traffic, one for front-end web requests, another for remote management, each on a different subnet with stricter rules. The number of NICs depends on the VM size, but the principle is the same: separation of concerns. Every Azure virtual machine requires a private IP address. That's how resources communicate inside your virtual network. A public IP address is different. It allows traffic to enter from the internet. Ask yourself one question. Does anyone on the public internet actually need to connect directly to this server? If the answer is no, don't assign a public IP. Web servers often require one because customers access them from the internet. Application servers usually communicate only with the web tier. Database servers should almost never be reachable directly from the internet. Reducing public exposure is one of the simplest and most effective ways to improve Azure security. A dynamic public IP is fine for a test VM. But the moment something outside Azure needs to reach it reliably, a DNS record, a firewall rule, an external partner, you need a static IP. When you create a public IP resource, set it to static. It remains allocated to your subscription even when the VM stops, so your services don't lose connectivity. It's a small price for operational peace. In the portal, jump to Create a Resource and search for Network Interface. Inside the IP Configurations blade, flip the private IP from dynamic to static. Give it the exact address you reserved earlier. Then add a new public IP. Set the SKU to standard and the assignment to static so it survives VM restarts. Finish the wizard and you've got a NIC with a permanent footprint. Quick reality check. Your demo VM had a dynamic public IP. You shut it down to save money. Come Monday, you power it back on. Is that IP still yours? Think for a sec. Normally, every packet passes through a software-based virtual switch. Accelerated networking gives your VM a direct path to the physical network hardware using SRIOV, Single Root I/O Virtualization, which partitions a physical NIC into multiple virtual functions, bypassing the hypervisor. The result: lower latency, higher throughput, and you can enable it with a single flag. While many common VM series include accelerated networking, you must verify your specific VM size in the official Azure documentation. Coverage varies by SKU. If your VM qualifies, there's typically no extra charge, so there's no reason to leave it off. It's a free performance upgrade that gives your VM a direct path to the physical network hardware. A single flag is all it takes. First, deallocate the VM. Accelerated networking can't be changed while the VM is running. Then update the NIC with Accelerate Networking set to true. After you start the VM again, every packet gets the fast lane. Two very different things to keep in your head: the piece of silicon magic that makes accelerated networking possible, and the wallet-draining oversight that nobody wants to repeat. Think of a network security group as the security guard standing at every entrance to your network. Every packet entering or leaving a subnet or network interface must pass through that guard. The guard checks a list of rules. Where did the traffic come from? Where is it going? Which protocol is it using? Which port? If the traffic matches an allow rule, it continues. If it doesn't, Azure blocks it automatically. Instead of asking, "What should I block?" start asking, "What absolutely must be allowed?" Everything else stays locked out by default. That's the mindset behind zero trust networking, and one of the most important habits every Azure administrator should develop. Every rule is defined by 5 pieces: source IP, source port, destination IP, destination port, and protocol. Rules carry a priority between 100 and 4096. Lower numbers win. Here's the crucial part. Inbound traffic from the internet is denied by default. Only what you explicitly allow passes. But within a subnet or heading outbound, Azure's built-in rules permit traffic, so you don't need to allow internal chatter. That's the real default behavior. Don't get caught assuming everything is locked down. Every NSG arrives with a set of built-in rules you cannot delete. They permit traffic within the VNet, allow load balancer probes, and enable outbound internet access, but block everything else from outside. This deny by default posture is your safety net. You build on top of it by adding your own allow rules. Here's the real CLI command. Notice the name, allow RDP from Office. That tells any admin exactly what the rule does without opening a document. The source address is your Office's public subnet, not the entire internet. That one restriction already blocks 99% of brute force attacks. 2 conflicting NSG rules. One allows, another denies. In practice, Azure processes rules from lower-numbered priorities to higher, and the first rule that matches is the one that applies. Keep that in mind. And when we remember the developer in Part 1 who forgot to shut down a test VM, imagine the same negligence with an overly permissive rule. Both cost you big if ignored. Imagine you're the ops lead at a growing SaaS company. The dev team just deployed the app. 10 web servers, 5 database servers. Without a smart grouping feature, you'd need 50 individual NSG rules just to let the web tier talk to the database. 50 rules. Then marketing demands 2 more app servers by Friday. Suddenly you're adding 16 new rules manually at midnight. That's the nightmare ASGs solve. Imagine your company grows from 3 web servers to 30. Without application security groups, every new server means updating firewall rules with another IP address. Eventually, your network security rules become hundreds of lines long and almost impossible to maintain. Application security groups solve that problem. Instead of creating rules for individual IP addresses, you create rules for job roles. Every web server belongs to the web ASG. Every application server belongs to the app ASG. Every database server belongs to the database ASG. Now your security policy says, web servers may communicate with application servers. Application servers may communicate with databases. Whenever a new virtual machine joins one of those groups, it automatically follows the same security policy without changing a single firewall rule. That's why ASGs are one of the most valuable features for large Azure environments. Here's the math. 10 web servers and 5 database servers. That's 50 source-destination combinations. 50 one-off NSG rules you'd have to write and maintain. With ASGs, those 50 rules collapse into a single rule. Allow traffic from ASG Web to ASG DB on 1433. That's the power of abstraction. Scale without exploding your rule set. Let's walk through this in the portal. In your VM's networking blade, click the network interface, then navigate to Application Security Groups. Add the ASG you've already created, say ASG Web Tier, and save. That's it. Now any NSG rule targeting that ASG will apply to this NIC without touching a single IP address. Let's put it all together. We'll build a classic 3-tier app inside a single VNet, a public-facing web tier, a middle business logic tier, and an isolated data tier. Each tier gets its own subnet with an NSG attached at the subnet level. And each tier's VMs are grouped by application security groups. The diagram shows the flow. Internet hits NSG web first, then inside each tier. No rules yet. Those come next. Before we move on, let's solidify the rule flow. How does the business tier reach the database? Answer: over port 1433, and only because NSG data explicitly permits it, using the ASG business tier source and ASG data tier destination. No direct internet, no shortcuts, least privilege in action. Before the checkpoint, a quick definition for the architecture we just built. Azure Bastion is a fully managed PaaS service that provides secure RDP and SSH connectivity to your VMs directly from the Azure portal over TLS, without exposing them to a public IP address. Now, test your understanding. Apply least privilege rules across the 3 tiers. ASGs shine here. 35 servers, 1 rule. Group the 20 web servers as ASG web tier, the 15 app servers as ASG app tier, then create a single NSG rule allowing port 8080 from the web ASG to the app ASG. No IP lists, no duplicated rules. You define security based on workload roles, not individual addresses, and that scales effortlessly. Least privilege isn't about blocking everything. It's about allowing only what your application actually needs. Start with Azure's default deny security model. Then create the smallest possible exception. Allow HTTPS from the internet to your web servers. Allow only the web tier to communicate with the application tier. Allow only the application tier to reach the database. Restrict administrative access to trusted IP addresses, or even better, Azure Bastion. If a connection isn't required for the application to function, don't allow it. That's how modern enterprise networks are designed, not by adding rules, but by carefully deciding which rules deserve to exist. Here's a simple guide. Need to isolate workloads? Use subnets. Need to filter network traffic? Use network security groups. Need to simplify security rules across many virtual machines? Use application security groups. Need secure administrative access without exposing public IP addresses? Use Azure Bastion. Need to improve network performance? Enable accelerated networking. Each feature solves a different problem. Together, they form the foundation of a secure Azure virtual network. Service tags kill the need to ever hardcode a Microsoft IP address. They're named groups that Microsoft manages, and the addresses update automatically. Need a rule that allows traffic from all Azure SQL databases in West Europe? Use scl.westeurope as the destination. 6 months later, when Microsoft changes the underlying IPs, your rule still works. Tags exist for Azure Cloud, Internet, and every major service broken down by region. Use them, and you'll never get paged for a stale rule again. Network security groups are software-based, and they aren't infinite. Each NSG has a default maximum of 200 rules. You can request an increase, but that should be a signal to consolidate with ASGs, so keep an eye on your rule count. And when rule sets get large, processing overhead can creep in, especially with heavy east-west traffic. The fix? Use application security groups to collapse dozens of per-IP rules into a single rule referencing an ASG. A set of 50 web-to-database rules becomes one rule from the web server's ASG to the database server's ASG on port 1433. Your security posture stays intact, and your network stays lean. Naming things feels tedious, until you're troubleshooting a breach at 3 a.m. and every rule is called Rule Wise. The Kayasoft best practices note that descriptive names make audit and troubleshooting dramatically faster. For NSGs, pick a pattern like NSG subnet name environment. NSG web subnet prod. For rules, allow or deny, then protocol, then source. Allow SSH from office. It takes 30 seconds upfront and saves hours of confusion later. Ditch the generic Rule 42 nonsense. Time to lock in the key limits and shortcuts you just learned. Here's a two-parter. What's the hard cap on NSG rules, and what's the main strategy to avoid hitting it? Checkpoint. Best practices and Part 2 recall. Whenever you're designing Azure networking, follow the same process. Start by separating workloads into different subnets. Assign private IP addresses by default. Only expose public IP addresses when they are genuinely required. Protect every subnet with network security groups that allow only the traffic your application needs. Use application security groups to organize servers by workload instead of individual IP addresses. Enable accelerated networking whenever your VM supports it. Finally, monitor and review your security rules regularly, because secure networks aren't built once. They're continuously maintained. Follow this framework and you will design Azure networks that are easier to manage, easier to scale, and significantly more secure. Watching is step 1. Doing is where you actually learn. Your challenge: sign up for an Azure free trial. It often includes a credit and free services for a limited time. Check the current offer for exact terms. Then build this exact 3-tier setup. Create the VNet, the subnets, deploy a tiny B1's VM in each, and apply the NSG and ASG rules we walked through. Use the portal and the CLI commands from this video. It's a 30-day mission. Finish it, and you'll know Azure networking better than most paid engineers I've met. Then drop a comment and show us your diagram. One last thing before next video. Open a PowerShell session or Azure Cloud Shell in PowerShell mode and run get as network security group. Look for any rule where the source address is set to the asterisk wildcard. That's a red flag. Fix it today. In the next video, we build on this foundation with high availability sets, zones, and disaster recovery. Same no fluff. Stay sharp. If this series has already saved you a breach, a headache, or a bad design decision, do 2 things. Hit subscribe so the algorithm knows this content matters, and ring the bell. Your support keeps this no-fluff training free for everyone else trying to break into IT. On to the next one. Follow us on Twitter and LinkedIn for career tips between videos, and join our Discord to troubleshoot with other IT learners. All links below. The earlier parts of this Azure Masterclass are in the playlist. If you missed Part 1 on VM sizing or Part 2 on managed disks, go back and fill the gaps. See you in Part 4. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.